Hi, this is Tomer from XtremIO, and today I'm going to show you a demonstration of integrating Dell EMC XtremIO X2 with VMware Horizon 7.3 instant clones at VMware App Volumes 2.12. As you can see here, I have 32 ES6 version 6.5 ARM.1 cluster. These nodes are connected to 32 AppStack data stores, which prepared using App Volume and containing Office 2016. In addition, I have 32 3TB data stores storing the virtual desktops. Each data store is mapped to a physical LAN in our storage array. In addition, I have a template machine which is installed with Windows 10 32 bits and including the Horizon 7.3 agent, instant clone drivers, and App Volume agent. This machine will be the master image for our deployment. So first of all, I'm going to create a 4000 desktop pool. The creation of an instant clone desktop pool roughly follows the same workflow as creating a link clone desktop pool, and it is executed via the View Administrator portal. After a master VM has been created and a snapshot has been taken from it, I am selecting Add tab from the desktop pool window. As only automated desktop pools are supported, this type of pool needs to be selected. Here, I am selecting Floating User Assignment, but please note that from Horizon version 7.3 and above, dedicated user assignment is supported as well. Here, I'm selecting Instant Clone Type and my vCenter FQDN, which is registered with Horizon Server. Here, I'm going to select a pool ID for my Instant Clone desktops and proceed with the default pool values. Under the provisioning settings, we must set the naming pattern for the pool, the amount of desktop, which in our case is 4000, and how we want the instant cloned virtual desktops to be deployed. Every virtual desktops can be provisioned at once by selecting Provision All Machines up front. Here, I click Next as I'm not using vSAN. Now, I'm going to select the master image that I prepared, the snapshot I'll be using for the virtual desktops, the VM folder, and the ESXi cluster. As a resource pool, I select the cluster again, and finally, the data stores that will contain the virtual desktops. Here, I'll specify the domain and the Active Directory container for the virtual desktops, and then click Finish to start the deployment. As you can see, Clone Prep will be used to insert the desktop into the domain. Jumping back to the vSphere client, we can see that the first part of replicating the parent VMs for each of the ESXi servers has completed, and now Horizon is deploying the desktops. Like a linked clone, an instant clone share the virtual disk with the replica VM after the instant clone is created. The process of creating instant clone differs from that used for link clone in the following way. Using VM fork technology, which copies the parent VM to every host in the cluster, and then uses rapid in-memory cloning for a running parent virtual machine, and copy on write to rapidly deploy the virtual machines, meaning no outstanding data is written to the array, but pointers and VMware metadata. Now let's jump to the array and see what's going on there. We can see that during the provisioning, XtremIO X2 is handling storage bandwidth as high as 3.5 GB per second and over 190K IOPS. I will fast forward the video so we can take a look at the deployment results. It took only 22 minutes for all 4000 instant clone desktops to complete, resulting in a quick and efficient desktop delivery. This I/O pattern is caused by the way instant clones work. We can also deep dive into the new features of our new HTML5 web UI and see the block sizes distribution and CPU usage during the provisioning. On this tab, we can see that the most bandwidth used is 256 KB and 512 KB blocks, as these block sizes are configured at the VMware level against our storage array. This tab shows the CPU utilization of our storage controllers during the instant clone provisioning process. We can see that the CPU utilization of our storage controllers stay normally around 60%. We can also see here the excellent synergy across our X2 cluster, when all our active storage controller CPUs share the load and effort, as the CPU utilization between all are virtually equal for the entire process. Now that the deployment completed, let's jump to App Volume Manager and take a look at the app volume configurations. In our setup, we have 4 instances of app volume to operate as a cluster sharing SQL database. In this demo, I'm going to attach Microsoft Office 2016 using App Volume Manager, which basically allowed me to keep a clean stage of the master image and basically just attach the right application to the right users. Here, we can see that there is an Active Directory group called Login VSI, which have been assigned with this Office 2016 app stack. Once I log in with a user in this group, we can see that a new drive will be added to this specific VM. That is, of course, the drive that contains the attached Office 2016 application. In my setup, I created a storage group which contains 32 AppStack data stores, each one backed by a 30 gig XtremIO SCSI LAN. Basically, what happens is that once I package my application, app volumes replicate the same VMDK file, which in our case contains the Office 2016 VMDK file across all the different data stores that I designated in the storage group. Please note that using direct-to-host connection for app volumes reduces the CPU and memory utilization significantly, while App Volumes Manager directs ESXis to mount assigned app stacks without going through vCenter. When I connect with a user who is not in this group to a random desktop, you can see that Office application is not available, because Office is not assigned with this user. Now, I will connect with a user who is in this OU. As you can see, the AppStack volume has been attached to that specific VM using App Volume Manager, and I can go ahead and open pretty much every Microsoft Office application that is part of the Office 2016 that I packaged for this specific OU. When we open the Edit Setting tab for this specific virtual machine, we can see that a new disk has been attached to this VM. This is the packaged Office 2016 VMDK file that I captured earlier. Now, let's run the load of 4000 VDI VMs with app volumes. In order to test the load on 4000 VDI instant clones, what we are going to do is run Login VSI test, which is the industry standard benchmarking utility for VDI environments. On these tabs, we can see the amount of users, the knowledge workload type, which simulates a standard user workload, and the naming convention for the desktops. Now, we are going to launch 4000 VDI sessions in roughly 45 minutes, which simulates the morning storm when users coming to work. So let's start the test by giving a unique name and proceeding with the default values. When I click Finish, the launcher VMs will connect to each and every desktop, the app stack will be attached to these desktops, and the users will start running the load. We can open a random console to one of the desktops. As you can see, the Office app stack is already been attached to this machine, and the current user is performing generic daily tasks such as sending emails, compressing files, adding documents, and watching videos and websites. When we open the Edit Setting tab for this specific virtual machine, we can see that a new disk has been attached to this VM. This is the package Office 2016 VMDK file that I captured earlier. Now, I'll fast forward the video to the point where 4,000 users are connected and run simultaneous load in order to analyze the results. Now, when the test finished, let's go to the HTML web UI and see the results from array perspective. This tab presents us with a total IOPS and bandwidth seen during Login VSI Knowledge Worker profile workload on 4,000 instant clone desktops. We can see that the IOPS at the peak of the workloads reach about 90k IOPS, while the peak bandwidth is about 1.8 GB per second. Here, we can see a small rise in latency numbers as IOPS accumulate up to 0.4 millisecond at max for the entire Login VSI workload, but never pass this value. These numbers yield the great Login VSI result and provide a superb user experience for our VDI users. Here, we can see the CPU utilization of our XAMs during the Login VSI Knowledge Worker profile workload. We can see that the CPU utilization at the peak of the workload gets about 30%. We can understand that although this type of desktops save us much space and provide various advantages, the workloads are slightly heavier than full clones due to them being based on VMware in-memory metadata. This tab shows the block sizes distribution during the Login VSI Knowledge Worker profile workload. We can see that the I/O per block size remained the same for most sizes, while the bandwidth usage increases when more users log in into their desktops. Login VSI scores are determined by observing the average application latencies, highlighting the speed at which users' operations are completed. This directly lets us quantify user experience, since the measurements considered are at the application level. This graph is generated by Login VSI. The blue line in each of the Login VSI charts follows the progression of the Login VSI average against the number of active sessions. From the average shown in the graph, the application latency is much lower than the VSI max threshold watermark for 4,000 active users, 1,240 average versus 1,969 threshold for instant clones. VSI base score is 968, which is really great score, and we can see that all 4,000 sessions ran successfully during the test, so we have 0 stacked sessions. This shows why XtremIO X2 all-flash single X-brick cluster demonstrates a best-in-class delivery for user experience for up to 4,000 VDI users with room to scale even further. Thanks for your watching.